Today, we will talk about the types of altitude. In aviation, there are different concepts of altitude depending on their characteristics and practical applications. Here, we can mention the pressure and density altitude, which we discussed in a previous video. But we also have the indicated, calibrated, and true altitude, which we will see in detail in this video. So, let's begin with the indicated altitude. This is defined as the altitude indicated by an altimeter when adjusted with the current QNH. We can also say that this is the altitude corrected for pressure error. In other words, when the current QNH is adjusted, the reading is automatically corrected for pressure, thus obtaining the indicated altitude. This pressure correction is necessary since the pressure at sea level is not always the same, meaning that we need to change the barometric reference in order to obtain the correct altitude indication. Now, the thing is that, by default, the altimeter is calibrated to measure the correct altitude above sea level under standard conditions. And as we already know, under standard conditions, the pressure at sea level is 2992 inches of mercury, or 1013 hectopascals. So, this means that under standard conditions, with the default altimeter setting, the indicated altitude and the actual altitude will be the same, and therefore, a correction for pressure is not required. However, if there are higher than standard pressure conditions, the isobars will move upwards, and therefore, the pressure at sea level will be higher than 2992. In this particular example, it is 3040. In this situation, if our altimeter is still adjusted with the default setting of 2992, the indicated altitude will be lower than the actual altitude. So, in order to obtain the correct altitude reading, the altimeter must be adjusted with the current QNH, in this case, 3040. Now, on the other hand, the opposite happens if there are lower than standard pressure conditions. In this case, the isobars will move downwards, and therefore the pressure at sea level will be lower than 2992, in this case it is 2970. So, if our altimeter is still adjusted with the default setting, the indicated altitude will be higher than the actual altitude. So in order to obtain the correct altitude reading, we will have to adjust the current QNH of 2970 as the new barometric reference. With this then, it is clear that the indicated altitude is obtained when the current QNH is adjusted on the altimeter. However, the problem is that the altimeters are not perfect, they suffer from instrument error, which is caused by wear of the gears and mechanical imperfections. And there's also the position error, which is caused by pitted static system errors in pressure measurement due to maneuvers or changes in aircraft configuration, which we have already discussed in detail in the video about the pitted static system. As a result of these errors, we have the following concept of altitude, which is the calibrated altitude. This is defined as the indicated altitude corrected for position and instrument errors. However, usually these errors tend to be small, and therefore in practice it is normally assumed that the indicated altitude and calibrated altitude are roughly equal. Now, you might be wondering, how do we apply the corrections for instrument and position errors to obtain the calibrated altitude? Well, the manufacturer publishes an altitude calibration table in the aircraft manual, which specifies the corrections to be applied in order to obtain the calibrated altitude. In this table, altitude, airspeed and aircraft configuration are taken into account to determine the correction values as we can see. So far, we have seen how the instrument and position errors affect the altitude reading. But there's another factor which also affects barometric altimeters, it is the temperature. This brings us to the concept of true altitude. As its name suggests, it is the actual altitude in relation to mean sea level. And in theory, it is obtained correcting the calibrated altitude for temperature error. And as we just said, the altitude reading is affected by the temperature of the air. For example, if an aircraft is flying under standard temperature conditions with the current QNH of 3010 adjusted on the altimeter, it will indicate the true altitude. However, if the temperature is lower than standard, even using the correct QNH, the true altitude will be lower than the indicated altitude. Otherwise, if the temperature is higher than standard, the true altitude will be higher than the indicated altitude. This error occurs due to the pressure distribution with altitude at different temperatures. For example, here we have the typical distribution of isobars under standard temperature conditions. Now, when the temperature is lower than standard, the pressure changes more rapidly with altitude, and therefore the isobars will be less spaced. On the other hand, when the temperature is higher than standard, the pressure changes slowly with altitude, and therefore the isobars will be further apart. And as we can see, the pressure at sea level is the same on all three cases, which means that the QNH is the same. The only thing that changes is the pressure distribution with altitude. This implies that under standard temperature conditions, the indicated altitude and true altitude will be the same, so a temperature correction is not required. But for example, if we are in high temperature conditions, the isobars will be further apart, and as we can see in this case, the true altitude is higher than the indicated altitude. The opposite happens if the temperature is low. In this case, the isobars will be closer together, and therefore, the true altitude will be lower than the indicated altitude. Now, in practice we may find a situation like this. Here we can appreciate the gradual change in the spacing of the isobars depending on the temperature. Note that the pressure at sea level remains constant, so the QNH is the same in both areas. This means that, if an aircraft flies from a high temperature area to a low temperature area, even though it uses the correct QNH, it will gradually descend, which could constitute a risk of collision with terrain. And conversely, if an aircraft flies from a low temperature area to a high temperature area, it will gradually climb, despite its altimeter will be indicating a constant altitude.